Hello, everyone. In the previous episodes, we learned about what Cilium and eBPF are and how Cilium takes advantage of eBPF. We also learned about Cilium networking model, security, and observability features. In this episode, we will learn about Cilium's cluster mesh, its architecture, and how to set it up, and we also discuss some use case scenarios. Note that in this video, we talk about cluster mesh and not service mesh. So these are two different things. Currently, Cilium's service mesh is under construction. But if you are interested to know what the service mesh is, I have another video that I talk about Istio service mesh. You can click on this pop-up here. So what is the cluster mesh? So after looking at and experimenting with Cilium cluster mesh, this is my own definition: a loosely coupled union of two or more clusters to share load balancing, high availability, observability, and security policies. It is not a federation to create a super cluster. So every cluster maintains its own independence, but they only participate in load balancing as mentioned above, observability, and also we can apply security policies across cluster, but each cluster will maintain its own independence. Let's say we have two clusters. I call them cluster 1 and cluster 2. Once we establish cluster mesh between these two, these are some of the features of the cluster mesh that we will get: service discovery and load balancing across both clusters, network policies, the policies that we can apply across both clusters again, encryption, and pod IP routing. Cluster mesh also has some prerequisites that needs to be met. The first one is each cluster must be assigned a unique human readable name as well as a numeric cluster ID. So there's a cluster ID, a cluster name that needs to be assigned to each cluster. And we'll go through that during the demo, how we can achieve that. The second one, which is also very important, is pod CIDR ranges in all clusters and all nodes must be non-conflicting and unique IP addresses. So we want to make sure that the pod CIDRs do not clash with each other. Again, we will set this up and we will meet this requirement during the demo. Nodes in all clusters must have IP connectivity between each other. This requirement is typically met by establishing peering or VPN tunnels between the networks of the nodes of each cluster. And lastly, the network between the clusters must allow inter-cluster communication. Now let's take a look at the cluster mesh architecture. Again, suppose we have, for simplicity, we have two clusters, cluster 1 and cluster 2. Each cluster has a master and node 1. I'm kind of replicate it here. So in order to actually establish the cluster mesh between these two, the first thing that we need to do, we need to enable cluster mesh service on each side of this or each one of those clusters. So the command is Cilium cluster mesh enable -- context cluster 1. And then we also need to specify a service type, because these two need to be able to communicate with each other. And the way Cilium does it is actually creates a service between these two clusters. And we have a number of options, either load balancer, node port, or cluster IP. But whatever method that you select, you want to make sure that the cluster will be able to communicate with each other. For production environment, load balancer is the most robust, because if you have multiple nodes here and one of the nodes goes down, then the load balancer will kind of switch to the other node. So it kind of behind the scene does the fault tolerance. If you use node port, which is another option, then if you're using this node 1 as part of the meshing process, and is binding to node 1 and node 1 goes down, then you need to go back and reestablish the mesh and then connect to node 2. So this is not very good. So for production environment, I definitely recommend set up a load balancer between the two. Okay, once we run that, then Cilium creates a cluster mesh control plane. So we have a Kubernetes control plane installed in the master. We will also have a control plane. Now this is a Cilium version of control plane. This is for managing the mesh. Then we need to do the same thing on cluster 2. We need to enable a cluster mesh service. We do the same thing over here, and once we run that, then it will also create a cluster mesh control plane on the second cluster. And finally, now that these two are ready, we need to run another command, which is now Cilium cluster mesh connect. So the keyword here is connect context cluster 1 dash destination context cluster 2. Basically, we are saying connect these two and create a mesh between them. Once it is run, then Cilium agent on one cluster will start listening to the API server. So all the events such as creating new services and endpoints, or if any changes to the endpoints and services on one side happens, the other cluster will be alerted through the agent running on that cluster. Same thing from here, the Cilium agent over here start listening on the API server, listening for the events related to services and endpoints. Now let's say we want to deploy a service that will be load balanced between these two clusters. How do we do that? So it's actually very simple. We define the service as we normally do, which is the kind, the service, and the metadata. We name it whatever we want. I call it hello world. And this is the part which is now we add this annotations, which is Cilium specific. So io.cilium/global-service equal to true. So this is the kind of the key phrase here. And once we do that, when we deploy that, then this service will be categorized as global service. And again, under specs, we have the cluster, the type is the cluster IP, the ports, which port will be listening on, and so on. So no difference really here, any different than normal services that you create. And we have to deploy the service on both clusters. So it doesn't propagate. So if you just say, I deploy this to this cluster and automatically will propagate it to cluster 2, it won't do that. So right now you have to manually deploy the same service on both sides. So let's go ahead and let's say we go to the command line, and now we have this YAML file, and we're going to, it's called myservice.yaml, and we're going to execute that. Let's see what happens. So it talks to the API server, it creates the endpoints here. API server calls into the Cilium operator, and then operator calls into API server, and also it persists that endpoints, those endpoints that were just created up here. We also have a version of that now in the cluster mesh. And then API server agent will know about that as we specified before. Cilium agent will be listening on new events, and this is a new event. We have a new service with new endpoints, and that will be communicated to the other cluster. And on cluster 2, we do the same thing. We deploy the YAML, and then we run it. It goes through the same process, and that's how it's done. Now let's see how global load balancing and high availability works. And I said sort of high availability because it doesn't really provide full tolerance yet. I'll discuss that. I'll talk more about that a little bit later. So for now, let's assume we have our own cluster 1 and cluster 2 that we just mentioned earlier. Same thing here as I showed you before. The only thing that I've added here is Cilium VXLANs, because by default, Cilium uses VXLAN in order to route calls from IP from the pods on one node to the pods on the other or on another node, and also in this case uses VXLAN to actually route calls from one side of the cluster to the other, so one cluster to another cluster. It still uses Cilium by default. So it's not the only way. If all your nodes and clusters are in the same L2 domain, that is, there's no router between them, then you can use direct routing. But for now, let's say we use VXLAN in this scenario. So let's say we deploy an application. We have the front end and the back end services here. Now we need to create a service that provides global load balancing among all these backends here. So when the front end calls, sometimes the calls goes to the back end on this side and sometimes on the other side. So let's reuse our service that we just discussed earlier. Use the same hello world application. And again, the only difference that with the normal service is under annotations, we say io.cilium/global-service, and we set it to true. So let's go ahead and execute that. We're going to execute, again, we need to execute that on both. We need to deploy the service on both clusters. So let's go ahead and deploy those. And as again, it will create a service locally on this side and a service on this side. However, because this is global, and the call will be also load balanced amongst the load balancers here. So let's say that one of these pods is going to call the service. So this is the HTTP, curl HTTP, and the address of the service and the port that is listening on, 8080. Let's go ahead and run that and say the first time that it hits a local load balancer and this pod answers. Let's say it calls the same service again, but this time it goes through the load balancer and it establishes a tunnel between these two sides. So, and then we need to add, because it's going through VXLAN, it needs to add additional layers of abstraction. So the first one is the Ethernet. So this is always happens. So this is the Ethernet frame. So that will be the MAC address of this server, the source, and the destination would be the MAC address of this server. And then Internet protocol version. So there will be IP address of this, the source, and this is the destination IP address of here. And then within that, user data protocol or UDP. So this is our UDP tunnel, the port number, and so on. So, and then within that, because it's using VXLAN, so VXLAN has its own header. So that's also been added. Then we have another layer, Ethernet frame. This is the source would be here because the communication is going through this interface and then through that and then goes to the other side. So we'll have the MAC address of this and then this destination MAC address over here. And then within that, finally, we have the IP address of the original pod. Since it went through this service and then it was picked up by Cilium here. So the destination changes from the IP address of the service to the IP address of the Cilium interface on the other side. So, and then when the call gets over here, the call is forwarded to one of these pods, and then the pod will respond and then goes through the tunnel again in reverse until the pod gets resolved. So if you're new to VXLAN and you want to know more, I have a full course on VXLAN. You can click up on this notification here. So anyway, it goes now through this load balancer and then this pod replies. So this is how load balancing works across clusters. So let's talk about high availability and how that works. Let's say we deploy a new service over here, and then we realize that there's a bug, and we don't want, when the pods are calling here, either from this side or that side, we don't want that this pods will be answering because there's a bug. We just discovered this bug over here. So we want to kind of take this pods offline so that service call will all go to the other side of our cluster. Let's say we have region A and region B. We want all the calls now go to region B for the service. So in order to do that, we need to run the command kubectl scale deployment hello world replica is equal to 0. So when we do that, it actually takes out all these pods, so we don't have any pods over here. So when the service comes in again, it goes, this time it always goes through the tunnel, and then these pods will be responding. So this is how load balancing works. And keep in mind that I just showed you the calls coming from this side, from this front end going to the other side. It could be from the other side. And the calls from the front end here when they call the service, sometimes they hit the services, and sometimes if these are not taken out of taken offline, the call comes through and hits the other service. So load balancing is the obvious use case for wanting to use cluster mesh. But there's another scenario that you might want to consider that, and that is if you have shared services, for instance, in this case, we have data services that might be consumed by many other clusters or many other applications. And especially if you have this application are mostly stateless, and these are stateful. So you want to separate them out. It may make more sense to have your data services in its own cluster, which is now shared by other clusters. And that provides, first of all, you can lock it down. You can have more deliberate time frame for deploying this, because for stateless services, you can always delete them and redeploy them. But that is not the case for stateful databases that you have. You can't just destroy them. So, you want to have more careful planning and more deliberate deployment. Then this would be another case for using cluster mesh. So you have, again, we have one cluster here that offering services such as data services that many other applications and clusters can take advantage of, and they don't have to deploy their own pods to do that. We will start our demos shortly, but just let's go through the process of see what we'll be doing. We'll set up a cluster called cluster 1. And again, if you recall, we need to specify a name for it. So we set the cluster name as cluster 1, cluster ID to 1, and then we set the pod CIDR for this cluster in this 172.0.0.0-16 range. So that would be our cluster 1, and then we go through the process how we actually do all this. And on the other side, cluster 2, do the same thing. We set the cluster name, and that name would be cluster 2 on the other node. And then cluster ID would be 2, and the pod CIDR we're going to set it to be 10.0.0.0/8, we will not have any conflicts between these two. So this will be our 2 environment, and then we will deploy an application and then and services that come with that application, and then we set up the global load balancing between them. So we're going through the application itself, take a look at the YAML file next, and see how the application works. Now let's take a quick look at our sample application. And this is the same application that we used in episode 2 of introducing Cilium. This is a Star Wars themed application and provided by Cilium team for testing purposes. So first take a look at the deployment. We have a deployment called Xfing. So this is basically used as a client. And again, there's nothing really new here. You already should be familiar with how to define a deployment. And there's another deployment. This is the deployment for the service, for the pods that the service will be built upon. It's called Rebel Base. Again, nothing really new here. The only thing Here, the kind of word mentioning is it uses a config map, and within that is defined a message. This is the message, and basically we specify what cluster is coming from. So there are two of this, one for cluster 1 and cluster 2. They're identical. The only difference is on this one, it says the cluster 1. So when we run the application, it says Galaxy whatever, and then it's coming from cluster 1. And then if the message is coming from the other cluster, then it says the same thing, but instead it says cluster 2. So nothing really spectacular here. And over here, it defines a volume because it wants to bind to this config map. So that's the only interesting thing here. And this is the service. Kind again is service. The name is Rebel base, and this is the annotation that we talked about: io.cilium/global-service equal to true. So let's walk through the process of setting up two clusters and connect them together to create a cluster mesh. And I put this in a number of script files to make it easier to use and understand what's going on. So the first one is called cube-prereq, and basically is setting up installing prerequisites on VMs that will be part of a cluster regardless of being master or worker node. Then I have set up scripts for setting up a cluster 1. For cluster 1, we are going to use Helm, because Helm allows us to decide what IP range we want to use for setting up future Kubernetes when they're installed. There's another method of installing using Cilium install, which is we will be using for cluster 2. But if you use Cilium install for both these clusters, then it will decide, it will use the same CIDR range, same IP ranges for future Kubernetes pods, and then that is not allowed because it will end up the IPs of the two clusters will be the same, which is won't work on a cluster. So we want to make sure that clusters have different IP ranges for the pods. So for cluster 1, we use Helm to install Cilium. And then for the second cluster, because we want to use the same certificate for Hubble. So Hubble is used to view and monitor the network. We want to have this kind of a single view of the network end to end. And then for that, we need to import the certificate or appropriate certificates from cluster 1. And if we use Helm, Helm doesn't have that option. So we need to use Cilium install to then import that certificate. So we'll have the same certificate used for Hubble on both clusters. So it is a little bit unfortunate that we need to use two different methods because one is lacking a feature, and I hope that the product team will kind of fix this. But as of now, as of recording of this video, is a little bit kludgy and clumsy, but we have no choice right now, and that's the way we're going to go and install it. So let's quickly go through the prerequisite scripts, and I've gone through that many times before. On line 6, we want to make sure that our Linux is up to date, so we update our Linux environment, the latest patches, and so on. Then we install Helm. So Helm is only needed really on cluster 1 master, but you can install it on other servers. It doesn't really do any harm. Then on line 12, we set up containerd because that's what we will be using for managing containers. Then these lines of code, they set up containerd and start the service. Then we work on preparing the installations of Kubernetes, and we need to download the GPG key from Google. We also need to add Kubernetes to the local repository. So those are the things that we need to do here. And then on line 27, we will install the command line for Kubernetes, such as kubeadm to actually initialize Kubernetes and kubelet and kubectl. Then we need to do a number of network-related activities here, and I'm documented here what they are. You can read it on your own. So basically, when we do that, after that, we need to disable swapping, because swapping is not supported on Kubernetes. So these these lines of code will disable swapping. And finally, then we can download the images that are needed, the container images that are needed to set up the cluster. So this is as far as the setting up the prerequisites are concerned. Okay, now let's move on to the second script file, and that includes instructions to set up our first cluster, cluster 1. So line 6, we initialize the cluster with kubeadm init, and then we basically create a folder called kube in the home directory, and then we copy the certificates which are in admin.conf in that folder over here under etc Kubernetes into that newly created folder, and then we give us access to that file we just copied. And then over here in this section, you want to make sure that once we have the cluster initialized and master is up and running, then we need to join other nodes to the newly created initialized cluster. And then we need to run kubeadm join, and then the token that was provided in this step. So when you're on step 6 at the end, when the Kubernetes cluster is successfully initialized, it will give you a token, actually the whole command, which basically is kubeadm join, and then you need to add the token that's provided here. You need to sh into each server and then run that kubeadm join. And then we have in this section install Cilium. We need to, first of all, download the Cilium CLI, and that's where you can get it. And then this line basically ensures that the file has not been tampered with. And then we unzip it, and then we copy it to that /user/local/bin. That will give you access to run it from anywhere on that VM. And then we update the Helm repository. We download the Cilium related repository in it. And then finally, on line 33, we are ready now to install Cilium. So let's go through the command here. Install Cilium, Cilium/Cilium. And this is the version as of recording this. The version was 1.11.2. So first thing, I want to make sure I'm in the right server here. Yeah, okay. Correct server here now. And then the namespace would be under kube system. And then we need to set the cluster name. I call it cluster 1. You can call it whatever you want, but it needs to be unique among other clusters that you'll be joining. And then cluster ID, again, this ID needs to be unique in your cluster mesh. And this is a kind of most important part of this whole installation, is we want to make sure that we set up a different CIDR, pod IP CIDR, because by default, when you run, if you install Cilium using the Cilium install, it will, all the pods will be in the .10.000/8 range. And then we don't want that. So we want this one, we want a different. So I'm setting this up to be 172.00016 range. So let's go ahead and run that. It takes a couple of seconds, and we'll see that it says it was successful. Let me clear that. And then in this section, we want to verify is to make sure it's actually everything is up and running. So on line 42, kubectl -l kube system get pods -l k8s-app equals Cilium -oy. So on each node, these are the Cilium created pods. And we want to make sure that they are installed and run, and they are ready. So you'll see that both of them show ready. So it's a good sign, and they are running. We also want to make sure that on line 43, all other pods, system related pods are also healthy and running. So let's take a look at them, and we'll see that they are all ready and running. You might run into a situation that core DNS may not be ready, or Cilium operator. So I've seen that happens quite actually often. So give it time, a few minutes. If it still shows not ready, then you need to reboot your VM, and hopefully everything will be working afterwards. And same thing on line 44, we want to make sure that our nodes are up and running, and we'll see that they're both ready, so it's a good sign. So once you verify that everything is good, then we want to again check Cilium status on line 47. So we'll see that Cilium is okay, operator is okay. Hubble, we haven't enabled that, and we haven't enabled cluster mesh. We'll do that next. So one thing that, so on line 51, we need to now enable Hubble, and this is the way to do it. Again, we need to use Hubble upgrade, Cilium, and then the Cilium version. Again, we specify the namespace, and then we need to specify that enable relay, Hubble relay enable true, and also Hubble true, enable true. So let's go ahead and run that. And it says that it was successful. So there's a kind of a problem here now. So in order to export the certificates from this Hubble to the next cluster that we're going to set up, we need to, this Hubble needs to generate a secret called Cilium.ca. However, unfortunately, when we enable Hubble through Helm, it doesn't generate that, so we can verify that. So kubectl gets secret -n, and that namespace is kube system, and then we're looking for Cilium.ca. If we run this, we'll see that it doesn't exist. So we need to do another step here. It's kind of silly. We need to again re-enable Hubble, and this time using Cilium enable Hubble, and then specify a -- create CA. Otherwise, we won't have that that secret. So it's kind of a little bit silly, but that's the way it is right now with this version of Hubble and Cilium. So we give it a couple of minutes in order to set things up, and then hopefully we'll have the certificates that, or the secrets that we are looking for. Let's give it a minute here. Okay, finally it's ready, and says it's ready. So let's go ahead and clear this. And then we try again and see if it now generates that Cilium/CA. And we'll see that now we have that secret. So that's what is required for our next cluster. And then we need to also download the Hubble CLI. So it's the process is similar to downloading the Cilium CLI. So we need to do the same thing. And then we can Cilium Hubble forward, so we can do a test. So basically that forwards, this will forward a port for us so we can communicate with Hubble. So let's go ahead and run that. And then we can do Hubble status. And we'll see that there are two nodes, and they are both of them are ready. You might see that one of them may be not ready. So be patient. Eventually, you'll have for whatever number of nodes that you have, you'll see that they're ready. And we can do a test on line 75, Hubble observe, and then we'll see that now Hubble is working. Okay, next we want to take a look at cluster 2 and how we set it up. Right off the bat, I've defined two variables called cluster 1 and cluster 2, and I'll show you what they are. So let's go ahead and execute those. Oh, by the way, I have to first switch to the right VM here. Okay, let's go run that again. Okay, so we need to, on the second cluster, we need to modify the configuration, the kube config that we have set up as part of our installation, which is over here. Once you set up your, so let's go through this. So we run the init as usual. We set up our, initialize our cluster, and then we create the .q folder, and then we copy the certificate or the admin.config that includes all the certificates into that folder, and then we give also permission to that. So once we do that, then we need to modify the config here, and we need to add the certificates from other server, because we have to now reference the first cluster that we set up in order to be able to import the CA, the Cilium CA secrets that was generated. So in order to that, we need to add a section here. We need to modify that. I'll provide this for you as kind of reference. So by default, when you run the init, you only have one section for cluster and one section for the user and context. So you need to add another section. So I call this cluster 1, and cluster 1 will have the certificate from the other server. So we need to copy this certificate section from the other cluster 1, add it here with the URL pointing to that cluster 1, and then add another section, cluster 2. So that will be your current the cluster that you'll be working, and to import the certificate to, and then you need to add section or the context, one cluster 1 and one for cluster 2, and then for each user you'll have a different user, one with different certificates. It's basically the same user, different certificates, one on cluster 1 and one cluster. So you need to modify that in order to be able to now be able to reference the other cluster. So and then you again join other nodes as we discussed earlier, and then you have your cluster set up. And then again you set up the CLI, download CLI, Cilium CLI, as we discussed earlier. And this is now actually the command that we need to run, Cilium install. So again, we specify the cluster ID and cluster name. So this one would be, ID would be 2, the name would be cluster 2. And then inherit, so this is an important section, inherit CA from user cluster 1. So let's go ahead and run this now. And it takes, again, a couple of seconds in order to set it up. And you can see it was successfully completed. So again, we run to the same, we want to verify, make sure you verify that everything is up and running. So let's go ahead and run that. Takes a second or so in order to come up. So these VMs are slow on the cluster 2 compared to my other cluster. So you see that this is not ready yet, so we just need to wait and run that again. You see that's still not ready, so let's go ahead and execute these pods and see what's going on. And we see that everything is good except these two. And look at our nodes. They're probably not ready because these are ready, so let's go ahead and run that again. And so you just wait for a couple of minutes. Eventually, hopefully they'll come up. Okay, since they're ready now, we'll see everything is ready. So we are good to go. And then we can finally, let me clear this. We can run Cilium status to make sure everything is up and running again here. So we'll see that Cilium is okay, operator is okay. So Hell, we haven't enabled that. And so also we haven't enabled cluster mesh. So this looks good. Let's go to the next section, and then we need to set up Hubble, and then just use Cilium Hubble enable, and that will enable the Hubble for us. Let's go ahead and run that. It takes maybe, again, depending on how fast your VMs are and how much memory you allocated, it may take a couple of minutes in order to set that up. Okay, it seems is finally completed. Now we can run Cilium status on line 47. Let's go ahead and run that. And then we'll see that operator is okay, Hubble is okay, so we have Hubble also enabled. And then over here again, we need to download the Hubble command line in order to be able to communicate with Hubble, and you can then run the test as we did the other cluster and make sure everything is ready. So we have two clusters that are ready. So we have the certificate, Hubble certificate that we needed from cluster 1 is now part of cluster 2. And now we are ready to go and actually join this together and set up a cluster mesh. Okay, let's go through the code now to actually create a cluster mesh for these two. I'm going to run this from a different machine, so this will be a different VM. It's not part of this cluster, so it makes it easier for kind of keep track of what we are running. So I'm running it from a different VM. And again, I've imported the config file from one of the servers here. So it will have, again, cluster 1 and cluster 2 as part of that configuration. Just want to make sure that on line 6, Cilium status, and then we look at cluster 1, want to make sure that everything is good. And we can see that everything is okay on this one. And we do the same thing on cluster 2. We want to make sure Cilium is healthy and running, and we'll see that operator is okay and Cilium is okay. So you're good to go. Now we want to enable service mesh. So as you saw here, you see that cluster mesh is a different server, which by default is disabled. So we want to enable that. Actually, you could have done that earlier, but I just want to show you how to run the command in order to do that from command line. So this is on line 10. We want to enable cluster mesh on cluster 1. So this is the command. Cilium cluster mesh enable -- context, and this is for cluster 1. A server type equal to, so we have a number of options how we kind of set up the communication mechanism between the various servers. Either we can use load balancer. So if you are in the cloud situation, this is the most stable one to use a load balancer. Because if we can also use node port, but if one of the servers goes offline and then may create problem for the cluster mesh. So it's better to use load balancer in a production environment. But if you're just testing it, you probably don't have a load balancer, then you can use node port. That's fine. I've set up a load balancer for my usage here for my lab. So I'm going to use that. We're going to run that. And we'll see that cluster enabled. I'm going to do the same thing for cluster 2. And so that's, let's run the command, and then eventually we'll see that cluster mesh is enabled. Let me clear that. So to verify, we can run this command, Cilium cluster mesh status context 1, and wait. Look at the status. And we'll see that it looks good here. Do the same thing for this one. And we'll see that that's also good. So we are now ready to establish, actually now that we have cluster mesh service set up or enabled on both these servers, let's go ahead and actually join these together to kind of form a cluster mesh. So Cilium cluster mesh connect -- context, and then cluster 1 -- destination context cluster 2. So this is how we actually set up the cluster mesh enabled between these two. So let's go ahead and run that, and we'll see that it tells us that these two are now connected. So that's a good sign. Let me clear this. Now again run the cluster mesh again. Make sure everything running good. So maybe doing some activity. So just wait a little bit in order to finish what it's doing. And we'll do the same thing here. Okay, it seems that now we have these two connected. So sometimes you need to wait a little bit in order to get everything ready. And at that point, then what we could do is now we could actually run some tests. So online, so in order to do the testing when you run your deployment, you need to deploy the same set of applications on both clusters. So you need to run, so this one I'm going to install a test application that comes with Cilium. It's a stalwart application that we used earlier, kind of a different version of that. So I'm going to run that. That will install that application. So the whole thing is just want to make sure that when we run it, we get results from both clusters. So it does the load balancing between the two clusters. Let's go ahead and install that on that machine. And maybe take, again, a few seconds to complete that. All right, that's done. Now do the same thing on the second cluster. So on line 29, we run the same, install the same application. Let's try again. Again, give it a couple of seconds in order to set this up, depending on how fast your machines are. So we'll see that now the application was created. Let's go ahead and clear that. Now we can run the application. So kube exec -ti, basically we are going inside one of the pods here, and then we call the service. So let's go ahead and do that. You see that the results is coming now from cluster 1, cluster 1, cluster 1, cluster 1, and then we'll see cluster. Eventually, we'll see that now will be load balanced between cluster 1 and cluster 2. Cluster 2, cluster 1, and so on. So this is how kind of quick walkthrough of how we can set up your Kubernetes clusters and mesh them together in order to have a more kind of load balanced environment, as we discussed in the presentation section. So we just saw the inter-cluster load balancing in the previous demo. In this demo, we're going to go a step further and see if we can fail over from one cluster to another. Let's say we deploy the application and the new version of the application on cluster 2, and then we quickly realize that there's a bug in that, and we want to stop the traffic coming to cluster 2, and we want to temporarily move all the traffic to cluster 1. So this is a scenario. Over here, I have the same application running 10,000 times in a simple loop. And then over here, then I want to set the replica set for Rebel-based application to 0, basically, and effectively, I want to say, don't send any traffic to cluster 2. So let's go ahead and run this. And you can see that it's load balanced. Sometimes it goes to cluster 1, and sometimes it goes to cluster 2. Let's go ahead, and now we realize that there is a bug here, and I'm going to set the replica set to 0. So let's go ahead and do that, and then we'll see after a while that all the traffic will be now coming to cluster 1. So over here, we'll see all the traffic now is directed to cluster 1, and that is the way that we want to. So this only works right now with kind of a planned failover. What I mean is, if the cluster, for whatever reason, goes down, let's say a cloud provider that you have one cluster on, it goes down. Unfortunately, Cilium does not recognize that there's a problem here. So it doesn't send any like heartbeat between clusters to see if one is down, and automatically it sends the traffic to the other cluster. So we've reached the end of this presentation, and I just wanted to share with you my final thoughts. Cilium's cluster mesh is a great start. It provides load balancing and routing across clusters. It also provides high availability for manually failing over clusters. But it does have some shortcomings also, which I'm sure they will be addressed in the future, but it's worth mentioning. One of the big ones is it does not provide full and automatic full failover when the cluster is crashed. So I experimented with it, and I simulated the situation when a cluster is not reachable. Unfortunately, the other clusters still send requests to that cluster. So it seems that there is no heartbeat function or feature between the clusters, and if one goes on, the other ones are not aware that this is happening. So obviously, this needs to be, in my opinion, needs to be addressed. And actually, I reached out to the team through a Slack channel for this feature, and they asked me to create a request, which I did. So hopefully this will be included in the future versions of the cluster mesh. Also, as far as network load balance, network policies, although it supports L3 and L4 currently for providing network policies across clusters, it doesn't support L7 unless you're using direct routing and you're not using VXLAN. Again, in my opinion, this is not sufficient. They should also support VXLAN. And again, I'm very sure that this will be added in the future as well. So that for this reason, I did not demo the network policy. I want to wait until they have a complete story before I do another demo and include that as well. So thank you very much for your time, and I hope to talk to you soon. If you like this presentation, give it a like and also subscribe if you haven't done so. Thank you.